Hi everyone and welcome back. In our last video, we talked about variables and basic data types, which are the building blocks of structured text. In this video, we will make our program think and react. And for this reason, we are going to talk about control structures. And there we will see if statements, case statements, for loops, and also while loops. And these control structures let your PLC make decisions and repeat actions automatically. Without any further wait, let's move on. Like said previously, control structures actually tell our PLC when something should be done and also how many times it has to be done. Let's start with the if statement. This is how the if statement in structured text looks like. So we have first the if and a condition. If the condition is satisfied, then there is a code that we need to execute, and we put this code here just beneath the then. If it's not satisfied, it directly jumps and comes and execute the code which is after the if without executing the code which is inside. And I would also like to mention that this is just for explanation, and you have to remember that your statement needs to end with a semicolon. It's also possible in an if statement to have an else section. So when the scheduler comes to execute this code, he will check if the condition is satisfied. If it's satisfied, it does this. If it's not satisfied, it executes what is in the else case, and then it continues. It is also possible to have many conditions. And this, with the if statement, you can use the else if. Therefore, we have maybe condition 1. If the condition 1 is satisfied, then we execute this part of the program. However, if condition 1 is not satisfied and condition 2 is satisfied, then we execute this part of the code. And if none of these two are satisfied, then it will execute the else part. Another control structure is the for loop. The if statement tells our PLC to execute a code when a condition is satisfied. So that is the when. But for the for loop, it's mostly for the number of times. This is the description. So it's for example, we have a variable, which is we give a starting point and an ending point. For example, in this case, the variable I will start from 1 and till 5. So this means when the scheduler reaches this point, the variable I is first set to 1. The code is executed, which means executed for the first time. Then it comes again, sets the variable to 2, execute again the code for the second time, now with 2. And so on until it makes the value of I to be 5 and executes the code with the value of 5. And once this code is executed 5 times, then the scheduler jumps and leaves the for loop. Another control structure is the case statement. It works more or less like an if statement. However, it is mostly used when you have just one variable which can have different values. And for example, in this case, we have the variable, and this could be an integer or whatever. It could be something that could hold a number, for example. So if this variable is 1, then we execute this code. If it's 2, we execute the code for when the variable is 2. And in the case, we can also have an else to mean that if the variable is not 1, it's not 2, and it's not 3, then it would execute this else part. And one thing that we would also see in some future video is that we can use this control structure for steps, maybe for running a machine, if a machine needs to have different steps. And it's also possible to leave from step 1, or in this case, from case 1 to case 2. So, but this we will see in future videos. Another type of control structure is the while loop. So we have the while and then the condition, and we say do. So as long as this condition is satisfied, the code will be executed. So the scheduler will execute this code and check again if the condition is satisfied. If yes, the scheduler will execute the code and execute the code as long as the condition is satisfied. The while loop is actually a loop that you need to be careful when you're using it, because it is possible that this condition is satisfied and that your program will run forever in this loop, and this might cause your program to crash. That's it for this part. Now let's move to the practical part where we are going to use these control structures in our program. So now we are going to start with the if control structure, and the idea is we would like to create a simple control structure where we want to start a motor when the button start is pressed, and stop the motor when the button stop is pressed. And if none of the buttons are pressed, then the motor continues in his state where it was before. So, and to do that, I would start by creating a variable b start, and this would also be a bool. I would also maybe create a motor bool, which is a bool. And here in my control logic, I would say if b start, then I would set my b motor to be true, else if b stop. So then I would just copy my b motor and I would put an else. B motor is B motor. Normally, this action is just meaning that we don't change the state of the variable. So I can actually write here, do not change the state of the motor. And now we have two end ifs. So I'm going to remove one of the end ifs. And that's it. So at the moment, I would build my program to see if it has any errors. It doesn't seem to have, so it's compiled. Now I will load my program to run the simulation. I will put the B start to false. And in this case now, the motor continues in the state where he was. We see that the B start is false and also the B stop is false. So none of these conditions are satisfied. And therefore, the else part is executed, which means that the motor keeps his position. So it was on and then it stays on. And now I will take the B stop and write the B stop to be true. I go to here, right? And then the motor is now stopped. So because B motor is false. So I will also again put the B stop to be false. And we see that now none of these conditions are satisfied, but still the motor keeps the position that it was. So it was false or the motor was not running. And in this case, it still remained false. So I will go offline now, and I will stop the run mode, go to config mode. That's it for the if control. And now we move to the case statement. Sometimes you have more than 2 or 3 options. And in this case, the case statement is cleaner than the if statement. Actually, what we are going to do now, the if statement can also work. However, it's much more cleaner to use in this case, the case statement rather than the if statement. And let's take an example. In this example, we would have a system or a motor which has different operating modes, and we would switch between the operating modes depending on the value of an integer. So what we need is an I mode, which is an integer, and also we would need a string, which in this case would be a status. So I just start with S, and this would be a string. And in my control structure, I would say case I mode of. And here I would say the different cases, 0. So if it's 0, if I mode is 0, then I would say that my S state stop. And I would repeat this also if it's 3. So when it's 1, I would say here it's starting. So the status would be starting. When it's 2, I would say running. And if the status is 3, I would say it's in error mode or error simply. So again, a brief recap. So we have the I mode, and this I mode is an integer. It can have values, positive values. So, and if in case that the I mode has the value 0, status of the motor is in error. However, we said this I mode is an integer, so it could also have a different value which is not listed here. And for this, I would say else S status. I would say here it is in an unknown state. So else here unknown. So now I will build my program. It looks like there are no errors. Now I activate the configuration. Now that we have the 0, because the I mode, as we can see, is 0. We have the I mode 0, the value is 0, but then the status is stop. So because here we said if the value of I mode is 0, then the status is stop. So if I change the value of I mode to 1, for example, so I write 1 and then I write 1 and then I write inside, then we see that the status is starting. This is what we have here. And if I change this to 2, for example, I click out of it first and then I say write, then it's running. If I go now and change this to 3, I first get out and then write. It's error, so it's in error state. Now, if I put something different that is not considered, for example, 20, it says unknown. And that's it for the case statements. The next control structure we are going to talk about is a for loop. And the for loop is great to execute a code or a part of a program a fixed number of times. And the example which we are going to see is that we will have a for loop where we have an integer which is from 1 to 5, and 5 times we will have to run in this for loop. My integer, I will call it I. So it's an integer, of course. And I would have some bools. Also, I will explain why this is like this. So I will have some bools. So B, let's say 1, a bool. And so what I'm going to do is I'm going to use the syntax of the for loop. So I would say for I equal to 1 to 5 is equal to 1, then B1, we would set this to true. So, and I will do the same for the other ones. So for the syntax, there is a do here, which I forgot. So for I 1 to 5, we do this. So I say if I is 3, then B4 would be true. And if I is 5, then B5. So this I is 5. So basically, I will explain again what this is doing. So basically, we have our for loop, which is the external loop. So this is what is happening. And like we said, we are expecting that the value of I in this for loop will change from 1 to 5. So, and to verify that I was 1, I would, at the start, all of these bool would be false. So 1, 2, 3, 4, 5, they will all be false. So to be sure that at the end, value of I has gone through the values from 1 to 5. And then I will load or launch my simulation. Okay. So I go online, update boot application. At the moment, it stopped. So everything is false, like we can see. And if I start the simulation here, we notice that now all of them are true. It means that I was first 1, then it also went to 2 and 3 and 4 and 5. So that's it for the for loop. I will stop. The next control structure we are going to talk about is the while loop. While loop functions almost exactly like for loops. However, it keeps running until the condition is false. And therefore, you need to be careful when using while loop, because if the condition is never false, it can run indefinitely and might cause your PC to freeze. Let's take an example. So for the while loop, we would need a variable that we would call j, which would be an int, for example. Using the variable j, we would use the while loop. We would say, for example, while j is less than 10, we would do. So this means while j is less than 10, we have to execute what is in here. We would say j into j, we would put j plus 1. So we are incrementing basically j. So this means as long as j is less than 10, we have to do what is in here. When I go online, I will update the boot application and I will start the simulation. And we see that j is now 10 because j started with 0 and every time it's incremented. And now because it's 10, it stops because we say if it's less than. So it was 9 and 9 was less than. So it executed for the last time and then made the value to be 10. And now when it's 10, it cannot execute the while loop anymore. That's it for the while loop. And I would also like to say that it's possible, and that's even the objective of programming at all, is that it's possible to combine these various logic to be able to build automation or to build software. And this we will definitely see in future videos, how to combine these logics to be able to build automation. As a quick summary, the if and the case control statements are used to tell the PLC when it has to do something, and the for and while loops are used to tell the PLC how many times it has to do something, which is automation. And mastering this means that you can actually create software which can intelligently respond in real-life situations. In our next video, we will see how to organize our code as programs, function blocks, and functions. And these are the 3 main building blocks of TwinCAT 3. And that's where your software really starts to look like a professional PLC software. You can find in the video description the link to download this program so that you can also test it from your side. Thanks for watching, and I'll see you in the next one.